Welcome to Path4Math. I'm your mathematics instructor, Dr. Kristi Dorman, and today we're going to be talking about the 2017 AP Calculus exam. Every video is in its own one of the 6 problems. This is question 1, parts A through D. College Board allows students to use a graphing calculator on question 1 and 2, and so I will talk about those with the TI-84 keystrokes. Also, if you want to see question 2 with those keystrokes, be sure to watch problem number 2. This is problem number 1, 2017 AP Calculus. And so when you read this problem, you see that the question asks about, they give you some data, they give you the height of a tank, and they give you the area of the tank. And then it tells you in the first part of the problem that the tank height is 10 feet, and that's the data points that are given across the first row. The area of the horizontal cross-section of the tank at height h feet is given by the functions a, where a of h is measured in square feet. So that tells me that a of h is measured in square feet. I know if I took the derivative of it, I would get feet. So if it's asking me about something in feet, if I integrated that, I would get cubic feet. And so I know that just by looking at the units that this problem is probably going to ask me about the volume, because the volume is going to be cubic feet. And they gave me, without even reading the question, I see based on this data given that they provided something in square feet. So I'm anticipating that. It also said the function's continuous. That means you can integrate or take the derivative. And it decreases as h is increased. So we know that the area and the height are inversely proportional. Question A says use a left Riemann sum, so LRAM, with 3 subintervals indicated by the data in the data to approximate the volume of the tank. So in part A, they ask us for volume. So to get volume approximated, they ask us to use a left Riemann sum with 3 subintervals. And so I'm going to use the intervals that go from 0 to 2. That's going to be the first interval. From 2 to 5 is going to be the second interval, and for 5 to 10 is going to be the third interval. And with an LRAM, you're going to use the endpoint 0, 2, and 5, and not the 10, because the rectangle doesn't start at 10. The rectangle goes from 0 to 2, then there's a rectangle that goes from 2 to 5, and then from 5 to 10. So to approximate that volume, you would simply do the height of the first rectangle, which is the height at point 0. So it's 50.3 height times the width of that rectangle. That rectangle goes from 0 to 2 units, so that's 2, plus the height of the second rectangle, which is 14.4, times the width of the rectangle from 2 to 5, so that's 3 units, plus the height of the third rectangle, which is 2.9, times the width of that third rectangle, which goes from 5 to 10, so that's 5 units. So what we're doing is we are breaking that region up into 3 rectangles, and then we're adding the area of those 3 rectangles. You type that into your calculator. It's calculator active. All you have to then write is 176.3 cubic feet. Then that's the answer. That's full credit, part A, and that was worth a point. The LRAM and the LRAM approximation together was worth 2 points. So you get a point for showing this part of the work, and then you got a point for this approximation. Then in part B, the question says, does the approximation in part A yield an overestimate or an underestimate of the volume of the tank? So if you could sketch this out, but every time you're doing an LRAM and you know that A is decreasing, then by definition, it is an overestimate. So all I'm going to write here is an overestimate. Because LRAM with decreasing function, or in this case, A of H. Full credit, that's 1. Now I've earned 3 out of the 9 points available for this question. Part C. They introduce a new function in Part C, an f of h. And Part C says the area in square feet of the horizontal cross-section at h is modeled by this function f of h. And they give you a function. Based on this model, find the volume of the tank and indicate the units of measure. Well, it says the area in square feet, and so we're reading square feet here, and I know that square feet, if I integrate that, I'll get cubic feet. So all I need to do here is integrate this function to go back to cubic feet. So I'm simply going to have volume equals the integral from where the height initially is up to where the maximum height goes of this function, f of h, that they just gave me. And then I'm going to write dh. And I'm not going to do anything else except for on a TI-84, type this into Math 9. Math 9 will open up an integration application, and you just type in, you don't have to write it here to get full credit. You just type in 50.3 over e raised to the 0.2h plus h. You could use x's there and then type in dx into that part of the calculator, and it will yield the answer, which is 101.325 cubic feet. That's worth 2 points of the 9 of this free response question. It is strictly a calculator question. Rest assured that on question 1 and 2, there will be a Math 8 or Math 9, or maybe even both questions when you're using an 84. Remembering that Math 8 takes the derivative and Math 9 does the integral. You will have to do that. You don't have to write anything else to get all the points. Let's look at Part D of this question. Part D says, water is pumped into the tank when the height of the water is 5 feet. The height is increasing at a rate of 0.26 feet per minute. Using the model from Part C, find the rate at which the volume of the water is changing with respect to time when the height of the water is 5 feet, indicating unit of measure. So this is a related rates question, asking you to take into consideration the f of h function that was given in Part C, and then it asks you to find the rate of change of the volume. So that is dV dt. How fast is the volume of the water changing at a single instant? So I'm going to evaluate that at the height is equal to 5. So it's kind of weird, right? That dV dt doesn't have an h in it. So you got to figure out how to do some, for lack of a better word, dimensional analysis. I could take the derivative of that volume function, and I could write, well, dV, but I can write the volume with respect to h. So I could write dV dh. But if I think back to dimensional analysis, I need something right here, and I need a dt left. So what I need in that numerator right there is dh. So that what I would be left with when I do that dimensional analysis is a dV dt. So, well, what does that look like? Well, dV dh is simply the derivative of question C. Well, question C gave me the volume, so its derivative is simply the f of h function. That is that whole expression right there. Then you've got to multiply that times dh dt. Well, dh dt is a Math 8 question. I would take the function for h equals, and I would type that right into my calculator at h equals 5. And when I see that, I simply get f of 5. So I'm going to evaluate that. I'm going to put a 5 into the function defined in Part C, times when I type into Math 8, into the TI-84, at h equals 5, I get the number 0.26. And when I figure those two values out, I get 1.69, and that is cubic feet. That's dV per inch. So let me make that an inch. So what does that mean in interpretation, right? Well, it means that when the height is 5, when the height of the volume of the water is 5, or when the volume of the water has a height 5, the volume is changing at a rate or it's increasing. And I know it's increasing because that value is positive. And that's how you get all 9 points on the AP Calculus 2017 question 1. Please reach out with any other questions.